I'm a developer advocate at Couchbase. Couchbase is not CouchDB. The two companies, they have some relation in the past, but Couchbase is Couchbase server. If you would like to tweet about this, please use hashtag Couchbase so my boss knows that I'm just playing around here. And if you want to follow me on Twitter, at Denis WS Rosa. Okay, so let's talk about microservice, right? So the thing about microservice is that no one really wants it. What I mean by that is monoliths, they are simple, they are consistent, they are easy to develop, right? But what happens is over time, they just become a big ball of mud, they are hard to scale, and they could not have high availability. And due to the requirements that we have today, we had to develop distributed systems, right? But the problem with the distributed systems is they are much more complex than monoliths in general. And most of the developers, they start developing microservices pretty much like they develop monoliths. And over time, what happens is they end up with some architecture called a microlith, which is much worse than you had before, because now you have basically the same problems, but distributed, right? And in order to make your architecture great, there's still a lot of work that have to be done in our architecture to make it, to get rid of some headaches. Okay, so if the monolith mindset is not the right one for microservice, which one is the right one then? And what I call this is, the right mindset is microservice, they come as a systems, so no microservice is an island, but they have to work autonomously, no matter if some service that you depend on is offline or not. And pretty much like humans, right? We rely on each other most of the day, like during some phases of the day, but most of the day we work autonomously from each other. And this is one mindset that we should have. We have to embrace reality and say, hey, even if the service that I rely on is off, I need to provide some level of service also. Okay, so I come with this term like autonomous microservice, but what actually from my point of view, define an autonomous microservice? And in order to have an autonomous microservice, from my point of view, I say that, your architecture should scale easily, should have some isolation from failure, should be resilient, and should be elastic. And when we talk about microservice, by default, we kind of are easy to scale, right? But not necessarily your architecture has some is isolated, is resilient, or is elastic. Okay, so then how can I make an architecture with some isolation from failure? And then we have this graph, which is basically the dependence hell, right? This is usually a side effect of bad governance. And sometimes, like when service 3, for instance, is having a bad time, you don't even can figure out what is the real effect in your architecture. Turns out that there isn't a way out of this. So one of the things that you can do is to cache data instead of asking for it. Let's give an example. For instance, one quite common problem is all your service need the user data. So every time you just make a synchronous call to your user service, right? So instead of doing this, what we can do is just listen to an event, and whenever the user data is changed, you can trigger an event, and all the servers will listen to this event and store the data they need. So even if the user service is offline, you already have the data you need, right? You are just querying locally. So you cut some of those dependencies by just caching the data you need. Another common thing that we have to use also is asynchronous calls, right? Actually, most of the communications between microservices can be implemented asynchronously. Just to give an example, let's say like Amazon, for instance, in an e-commerce example. Whenever you buy something to Amazon, in Amazon, you are just placing an order. Because actually, a few minutes later, you receive an email saying that, yeah, we got your we got your order. And then a few hours later, you actually receive an email saying, hey, we processed your payment. So everything is asynchronous. And this is beautiful because a user can always place an order on AWS, on Amazon, even though the payment service is offline. So that's the beauty of asynchronous communications. And yeah, most of the problems, they can be implemented asynchronously. It's just a matter of reframing the problem itself. I have a lot of stuff to talk. So basically, if you implement data caching, and most of the communications are asynchronous between microservices, you kind of have a very good isolation from failure. At least you can tolerate a few hours maybe of some service downtime. But what about being resilient? First, don't ever let anyone break your state. What I mean by that is, in microservices, it's quite common when you, sometimes another service has a bug, and then they send you the wrong data, and then because of this, you also send the wrong data to another service, and after a while, you just have this distributed inconsistency, and it's terrible to fix it, right? And sometimes you don't even notice this right away, right? You will notice this 1 week, 2 weeks, 1 month ago, and you don't know, hey, what's the origin of this problem at all? So one very good pattern for avoiding this is called event sourcing. So I wrote about this also in the Couchbase blog. And in event sourcing, you store all the change requests as events in a log. And your current state is just, you just process all those events, and then you end up with your current state. So you can even drop your current state and reprocess all the events again, and you will end up with the exactly same state. And this is really great because then you can go back and kind of go back in time and see what happened here. What happened? What was my state 1 week ago? And in which point the failure occurred? And you can maybe delete your state and reprocess the whole thing to get the right state. Another common thing for being resilient is to respect other servers also. Of course, you guys are familiar with timeouts, for instance. So whenever, let's say, service 2 is having a bad time for some reason, and then you make a request, and your request gets locked here, right? Because you're waiting for service 2 response. And then you have other requests, making requests to other service. But at some point, all the threads locked here consume all your thread pool, and your whole service goes down because of this service. This is how usually cascading failures happen. And if you think about, like, okay, how can I do this? Like, a very simple Java code will trigger this kind of error, right? And in order to fix this, you have to implement timeouts. So not just for the connect timeout, but also the read timeout, which means that how much time I will wait until another service will start streaming data to me. And yeah, we can be here the whole day just talking about possible errors in network. So we have auto retry. So if you get a bad gateway, probably you should try again. We have secret breakers. We have bulkheads and other stuff. And this is really complex to implement, right? And one of the most common frameworks that we have been, you guys probably saw before, is Netflix Hystrix, right? But there is a problem with that. Like, it works perfectly well, but hey, we are talking about microservices here. And if you are pushing all this responsibility to your microservice, a good amount of your code will be just for handling network problems. And not to mention that hey, this is for Java mostly, right? What about I have a code in Python? What about if I have Node.js? The other frameworks are implemented differently, and you have different statistics from each framework, and you can actually compare what's happening. And because of this, in the last 2 years, I would say another pattern arose called service mesh pattern. So the service mesh pattern is basically a proxy. The service mesh is a proxy. So instead of making a request directly to the right servers, you just make the request to the proxy, and the proxy will make the request to the right servers. And the good thing is, yeah, this is you can install a proxy here, and it will take care of all the network problems for you, right? It kind of really get rid of all the dependencies and all the implementation that you have to make in your application before. And when we talk about the most famous service mesh providers, yeah, we have currently Linkerd, we have Envoy, we have ICO. And one cool thing about those service meshes is statistics in general, so you can follow all the problems that you have with your network. Great, so we talked about being resilient, right? What about being elastic? So whenever we talk about being elastic, we have this like two most famous patterns, right? One is service discovery, and the other is load balancing, right? We need those two patterns for being elastic. And they have been out there for quite a while, probably is well known from most of you guys. But turns out that we don't need to do this anymore, at least not directly. When we talk about Kubernetes, for instance, if you define a service in Kubernetes, you get this service registry and load balancing for free. So this is basically how you define a service in Kubernetes, and that's it. Yeah, you have a cloud-agnostic way to implement like load balancing in service registry. Same thing. What about? But this is just load balancing in the service registry, right? What about outscaling? So with Kubernetes, we can also define our instance and how many replicas we want. So, okay, I want 2 replicas of this. And even if for some reason one of the instances get killed, Kubernetes will automatically start this new instance again. And if you have pod outscaler, which is another feature of Kubernetes, you can say, hey, whenever my application has 80% of CPU, please start a new instance. And this is how you can make your application elastic. Great, so yeah, I can say that, yeah, now my application is really elastic, right? So now I have a really highly scalable microservice. Wow. Well, not really. What about your database? If you think about databases, they are the biggest bottleneck of most applications. And as developers, we just expect database to work out of the box, when in reality it's the exactly opposite of this. You have to put a lot of effort in your database to make the performance of your application great, right? And we even have a dedicated person for this, like the DBAs. And now when we talk about it being elastic, now we have all those instances talking to a single database, right? So okay, let's just scale our database then. And turns out that scaling databases are not that easy, at least not the relational ones, because they were designed to run in a single machine. The original design is to run in a single machine. And when you run a cluster of Oracle or MySQL, the cluster itself is just faking a big machine. And that's why you have this limitation of, yeah, how many nodes can I have on a MySQL or on an Oracle cluster? And that's why we start talking about polyglot persistence, which is, hey, let's for each use case, let's use a different type of database, right? So if I'm implementing search, I probably will use Elasticsearch or Solar or even Couchbase. Or if I'm implementing recommendations, I can use a graph database. For when you need your structure has a lot of joins, probably one of the best options is to use a document database, which is what Couchbase is. And of course, if you need transactions, yeah, relational database have been there for 30 years doing transactions, and they are really great at it. So if you need transactions, yeah, go to a relational database. And yeah, this is what we call a Polygon persistence, like using multiple databases, and you don't have to implement or migrate your whole thing. Let's say, yeah, you load your whole user data in every single page with all the user preference and telephone numbers and all the stuff. And instead of loading this from a relational database, which means that you have to make a lot of joins, if you load this from a document database, it's a very simple get. So this is how people are building systems now. Like, okay, this data is in this database, this data in this database, and you leverage the best part of each one. How many of you guys have seen this video before? So, cool. So this is some folks playing Pokemon Go on a park in New York, and suddenly a Vaporeon appeared, and you have this huge flow of people going to the same place to catch a Pokemon, because back then Vaporeon was the strongest one. And yeah, if you think about Pokemon Go, they went from 0 to almost 300 million users in a month and a half. This is really impressive, and they got 1 billion in revenue in the very first year for a mobile game. And you can imagine, like, just by being highly scalable here during the bus, how much money they got. But of course, not everybody is Pokemon Go, right? Maybe you don't need to scale 300 million users in a month and a half, but it is about saving money, saving money with servers, making your application faster. And that's why it's really important to choose the right database. Just talking about Couchbase again. Probably document databases, they are the most common replacements for NoSQL because they are the closest you can get from a relational database. Couchbase itself is well known for being really high scalable. You can easily scale up to hundreds of nodes in the same cluster. So yeah, you can scale like all the big use case. Like Pokemon Go, they have like in the same node, in the same cluster, they have dozens of nodes. And we are memory first because we have managed cache under the hood. So whenever you write to something to Couchbase, you kind of, it's pretty much like you would write to memory database, but asynchronously we store the data in the disk. So it's really fast because we have managed cache. And you don't have to have this managed cache in your application separately. You already get all in an embedded one. Actually, you can even use Couchbase just as a managed cache. And because of this, naturally, is one of the fastest databases out there because most of the time you are just talking directly to the memory, and the server itself is taking care of replicating and it's storing the disk. But of course, via SDK, you can specify, hey, I would like to wait until this document is replicated or stored in the disk until you get the response back. Okay, but we were talking here about being elastic, right? So, and can my database be elastic? Because the problem is, applications in general, they are stateless, right? And databases is exactly the opposite. They are stateful. Actually, your application just pushes the state down to the database. That's why your application usually is stateless. And how can I make my database elastic if it is stateful? If it is stateful, turns out that we have a new pattern now called thanks to Kubernetes, we have a new pattern now called operators. How many of you are familiar with Kubernetes operators? Cool. So in Kubernetes, you can implement some specific behaviors. So whenever you implement one specific behavior, let's say, oh yeah, whenever I add a new server, I want to trigger some notification, for instance. You have to write a controller. And when you have a set of controllers for a given purpose, it is called an operator. And with databases, I cannot just add a new node, right? I have to add a new node, tell the other nodes to say, hey, there is a new node in the hood here. Please trigger rebalancing. And this is what operators are all about. Like, they will take care of most of the DBA works. It's an automation for it. And yeah, this is part of my demo. So if I want to deploy Couchbase on Kubernetes, for instance, I can just say, hey, this is my database, my schema. I will call this default. This is the memory. I want one replica and 3 instances. So I will start like 3 instances of of Couchbase in the same cluster. And with the operator, it will automatically start managing my database for me. This is exactly what I would like to show you guys today. So I will deploy a microservice application talking directly to my database, also in Kubernetes, and I will scale up and down both of them. So here I have my application. I'm using Couchbase with Spring Data. So basically, this is my main entity. I'm using Lombok here. And Couchbase, I only have 2 annotations, which is at document and at field. Even if I have any nested entities, I don't need to map anything like that. I don't need to map anything, just in the main entity, right? And in my repository, I can write find by company ID, and it will automatically generate an implementation for this. This is an interface, and match ID here with the company ID in my entity, and generate the DAO class for me. This is really powerful. And I can also additionally write some queries here. We have a very a SQL-like language called Nico. So yeah, if you know SQL, probably you know very well Nico also, and you can just write the same type of queries. Cool. And this is running, and I create a Docker image of this application using Spring Boot and Spring Data, right? So cool. Let's go to Kubernetes then. So, sorry. Here I have my Kubernetes cluster running. I can run Cuba Control, get nodes. So I have 3 nodes running on AWS. Let's wait. OK, 3 nodes running. And what I'm going to do first is to deploy the Couchbase operator, which is just the application which will take care of my database, right? So I run this, right, Cuba Control. Sorry, Cuba Control, create -f, operator YAML. And yeah, cool. So let's wait until my operator is running. Sorry. Pods.
Can you make it bigger? Slightly bigger, please?
Yep. Is it fine? Oh, sorry. Pods. Okay, so now my my operator is running, so I can deploy my database now. First, of course, I have to define the username and password that I'm going to use to log in my database. So in Kubernetes, we have to define a secret. So I will just create the secret. So in Kubernetes, we have to store this as base 64. So this means administrator, and this means password, So I run Kuba Control, create, -f, secret, and Q. And now let's deploy Couchbase. And here we have a Couchbase cluster. I want 2 replicas, and I want 3 instances of my database, right? So I run Kuba Control, create, -f, Couchbase cluster. All right. So you see that at some point it's starting out of my 3 instances here. In the meantime, I just we have to create, as we are going to deploy a microservice, I'm going to create the password that my application will use to log in Couchbase. So I have this Spring Boot app secret here, which means the password is just Couchbase sample. So I have Kuba Control, create, -f, Spring Boot application secret. Cool, and let's check if our database is already deployed. Kuba Control, get pods. Just 1. We should get soon the second one running, the third one running. Okay, so now we have here our operator, which manage our database, and here our 3 instances. So what the operator did here, like he already he noticed that we have a new instance, and he joined all those new instances in a single cluster and trigger rebalancing. Let's connect to our application here. So I just forwarding the port of one of the pods to my machine, and then I can access here Couchbase web console. And here I use administrator and password. Great. And here you see like all the 3 servers are already talking to each other, right? So let's add the user, Couchbase sample. And just to be faster here, let's use all the same thing. And yeah, define the user as password because I don't want to give the specific rule. Okay. Now we have our admin, and we are ready to deploy our application because now we already have the database here. So let's clear here, and let's deploy our application here. So just for you guys to know, this is my application. There's nothing special here. I'm just saying, hey, I want 1 instance of this application, and it's grabbing an image from Docker Hub. So Kuba Control, create, -f, Spring Boot app, YAML. Oops, sorry. Good. So now we have deployed both our database and our microservice on Kubernetes. Let's access our application now. So here I already have defined a service. Here it's already running because service usually take up to 15 minutes to run. So I already have defined here. So we can write kubectl get describe service. This is just a load balancing which exposes my microservice to the net to the internet. And yeah, and this is the public IP of the public address of my microservice. But in summary, what I did here is I just run this thing here. That's it. Like I'm pointing to my pod, which is Spring Boot app, and leave the port 8080 open. So now we should be able to access our application. I have here a service which just loads some dump data. Right here. Yeah, just load some dump data. So let's populate our database. Good. And now if you come back here to Couchbase and we query, yeah, we have 200 documents. Great, so here things are getting interesting. Let's say I want to scale my application, right? So all I have to do is go here and say, no, I want 2 instances of this application. And now I go back to console and say, Kuba Control, replace, -f, Spring Boot app, YAML. And Kuba Control, get pods. And magically, I have 2 instances of my application running. What about my database now? Let's scale my database. Wait, let's do something worse. Let's kill a node of our database and see what happens. So Kuba Control, delete pod, CB example 2. So now we just lost 1 instance of our database. Let's check if we lost any data here. So it will recognize that 1 instance is not running anymore. So here is when the operator will kicks in. He will notice that 1 instance is down, and it will trigger rebalancing to make sure that you have all the copies of the data. And the pattern in Kubernetes itself will start a new node and rebalance again to copy some data of those 2 nodes to the new node. So here, even if we come here to query, we still have 200 documents. We didn't lose anything. And if we come back here, hey, we already have another instance running. And we can come back here, and yeah, now we have 2 instances, and the third one will rebalance automatically. That's what the operator is doing here. He just noticed that 1 instance was killed, then dropped off the instance and joined the new one. What if I want to scale my database then? Okay, so we can just come back here to our database and say, yeah, well, you know, I want 2 replicas. No, I want 5 instances now. I don't want 3 is not good for me anymore. So I can just come back here, write Kuba Control, create, replace, -f, and a Couchbase cluster. And hey, that's it. We will wait. We have to wait a few seconds. It will automatically trigger some rebalancing here first, and then the thing is, as the operator will first, he have received the request to scale, but he says, hey, hold on, I'm rebalancing for this new node that we just lost, and after that I will scale your cluster. And eventually, what I'm going to have here is we are going to have 4 or 5 instances. Yeah, as soon as the rebalance ends. And this is really powerful because, hey, we are not talking about, I'm running on AWS, but I can do the same running on bare metal. I can do the same running on Google Cloud, on Azure. So you can design your whole infrastructure to run anywhere. And of course, you can just, using pod.scaler, you can configure, hey, whenever my database has 80% of CPU usage for 10 minutes, please spin up another 2 instances. And if they have been with CPU usage under 20% for 15 minutes, yeah, scale down this. And this is nearly state of the art. This is what we are working on right now. This is becoming a very standard pattern. Some other, you can find other operators for MySQL, for Postgres, but Couchbase was the first database company actually which released an official one, and we are putting a lot of effort on it. In the next 2 months, I think we are going to release even automated backup. So whenever you deploy Couchbase on Kubernetes, it will automatically start making backups for you and storing in a persistent storage. And we will probably finally reach this state that most of the developers would love to, which is just make your database work out of the box. In the meantime, here, so now we probably have our 5 instances running of our database. And this is the demo that I would like to show you guys today. So yeah, you can really adapt your infrastructure according to your demand and scale up and down to save a lot of money in servers, right? Because in most of the databases, sometimes it's easy to scale up, but scale down is a huge problem. And when you have this kind of thing, you just, hey, you can automate most of the stuff. And Couchbase, talking about our operator here, we have, right now, you can, we consolidate logs. So all the logs are in one place, because now, of course, when you have distributed system, you have to consolidate all the logs. We also have auto recovery. So if your node goes down, we automatically will start the node, your database node again. We have this elastic scalability, so you can scale up and down your database. And soon, as I mentioned, we're going to release backups and other stuff. This is what I would like to show you guys today. And if you have any questions, feel free to ask. Thank you very much. Go ahead.
One question. You scale the database and you scale the application, but it was only one operator. Can you also scale it?
Yeah, you can scale the operator, but usually we have some other specific triggers to, even if the operator is down, it will automatically recover and be restarted again. This is part of Kubernetes pattern, right? Like Kubernetes will notice that this node is down and get up again. So usually the operator is specific for Couchbase, for instance, because he knows all the APIs and how to join the node in a cluster. And most of the time, one node, one Couchbase operator is fine for each network. Yeah, go ahead.
Are the pods responsive when the rebalancing takes place?
Yes, absolutely. Yeah, because this is there is a very complex protocol to transfer and rebalance data. So we don't rebalance data as fast as we can. So we try to hold up a little bit to avoid compromising the performance of your application, right? And at some point, they just say, hey, I already have, in Couchbase, you have the data is already sharded. So whenever we copy a shard, this server starts assuming this other request for this shard. So you don't have to wait until the whole rebalancing is finished to actually getting better performance. Go ahead. In the latest version, we are also replicating. So sorry, the question is, do we replicate indexes also, right? Yeah, in the latest version, we started doing this because yeah, rebuilding index is a huge problem, especially if you have terabytes of data. And yeah, this is a common problem for some of big clients, and yeah, we are doing this now.
So the index is rebuilt automatically on the first time it gets the first read from the database?
No, what we have some replicas of the index also, so we can also just replicate the indexes also. Yeah. And again, Couchbase is we have a community version, so you guys can use for free and try for free. You can also try for free the enterprise one. And yeah, sorry, question.
Is the data for Couchbase stored on the Docker itself or on the host?
That's a very nice question. The thing is, in Kubernetes, right now we have two types of storage, right? We have the local ephemeral, and we have the remote persistent storage. And probably in the next 5 or 6 months, Kubernetes will launch the support for local persistent storage. Right now, we use ephemeral storage because the remote storage is, of course, remote, and it will affect a lot the performance of your database. But the side effect of this is if you kill your pod, not your instance, if your pod get killed, you lose the data in it. But when you in Couchbase, you can configure replicas of your data, right? So if you have 2 replicas, probably the chance of your pod like you lose some data are really low because you have copies of this, and once you start a new node, we copy this to this new. We copy the data to this new node. So you have always 3 replicas of your data, and that's why it's not that risky to lose data, even though we are using ephemeral storage. Of course, when Kubernetes launch local persistent storage, we are going to support this because this will be the ultimate solution for running databases on Kubernetes, because then even if your pod got killed, the Kubernetes scheduler will reschedule another pod to run in the same machine. And that will be the ultimate solution.
What happens to the service when we scale up and down?
Sorry?
What happens to the service, availability of service, when we scale up and down?
What happened with which service? Sorry.
Availability of database service.
No, well, the question is, what happens when I scale up and down? Do I have any downtime? No, not at all. Because your other nodes are already... this is one thing that... This is what we call about embracing the cloud, right? Couchbase is not a new database. It's already 5-6 years old. And it was born to be cloud native. So whenever you scale up Couchbase, there is no downtime at all, because you just spin up a machine and we start moving some of the shards to this new machine. And you can, like here, I scale up and down my database without restarting my application. Cool. Any other questions? Okay, so I'll be in the Couchbase booth. So if you have any questions, please stop and talk with me. Thanks a lot for coming, guys.